Those who can't remember the past are condemned to repeat it. That's sound like a philosophical statement, but it also resonates with the idea in dynamic programming. As we study data structures and algorithms, which is a fundamental topic or an idea in computer science or computer engineering, we look at different algorithm design techniques, starting from the brute force approach, then the idea of decrease and conquer or divide and conquer, also concepts like greedy algorithms, and as well as the dynamic programming approach of algorithm design. Dynamic programming is a powerful algorithmic design technique that can be used to solve complex problems by breaking them down into simpler overlapping subproblems. So the idea of solving an original problem by solving versions of its subproblems, it's very common recurring idea in algorithms or algorithmic thinking. We discuss it when we talk about recursion, when we talk about divide and conquer, or when we talk about decrease and conquer. But unlike traditional divide and conquer, dynamic programming recognizes that subproblems can overlap. So that is the key distinction in dynamic programming. We look at, as we go through a certain set of problems, we identify it has a recursive nature. There is a recurrence relation where we can derive the solution to the original problem as a collection of solution to its subproblem. So that we can derive a recurrence relation between the original problem and its subproblem, meaning problem of n versus relating it with the problems of n minus 1, n minus 2, etc. And in dynamic programming, pseudocode is not showing the details how the cache is implemented, but we can, of course, identify what is the suitable data structure to implement the cache. Here, because we are trying to retrieve a value based on a key, so the ideal data structure for that purpose would be using a hash map with such that we can retrieve the such that we can efficiently retrieve the value corresponding to given key. And the other thing is, if you want the steps to convert any problem to solving it using dynamic programming would be to first derive or identify what is the recurrence relation between the original problem and its subproblems, and then identify whether there are overlapping subproblems. And then using memoization so that we can reuse the already derived solutions anywhere or at the places where we want to reuse the solutions to those subproblems as we proceed to calculate or derive the solution to the original problem. And before winding up, to discuss on the time complexity to make it comprehensive and complete, if you look at this pseudocode versus the traditional Fibannacci pseudocode, what we see is that now we have come to a linear complexity in terms of n. We have converted that, we have come from an exponential complexity to a linear complexity in terms of n by adapting dynamic programming approach. And therefore, it is worthy to consider in cases where we have a certain recurrence relation between the problem we are looking at and its subproblems, and these subproblems are overlapping, so that we can look into whether we can apply dynamic programming to solve that particular problem.